quantum numbers are not going to be directly on the AP exam. They have taken that away, but it is considered prior knowledge. So if they talk about a quantum number, you should know what they're talking about. So first of all, let's define the four quantum numbers. So Schrodinger's wave equation, he used four numbers to predict where in space those electrons would be. And so it's kind of like his code for when he plugged it into the supercomputer. These numbers tell about the orbital of each electron. It tells the distance, it tells the shape of the orbital, it tells the position in space, so that would be X, Y, and Z, where you're going to see it, and also tells the spin. And the spin we have up and we have down. And you might say, oh, we did that in orbital diagrams. Yes, your orbital diagrams and your electron configuration are going to help you do these four quantum numbers. So here's what each of the quantum numbers letter example means. So when we have an N, that is a principal quantum number. This tells the energy level or the cloud size. It's also the row on the periodic table that you find the element. So if I'm n equals 1, I'm very, very close to nucleus. It's the first orbital. N equals 2 would be the second orbital or the second row on the periodic table. And n equals 3 would be the third row on the periodic table or the third energy level. It's also known as a shell. So first shell, second shell, third shell. That's what n is. N is the principal quantum number, tells you what row, what energy level. Let's next look at the sublevel. So the sublevel we've already been working with. You just might not know it was called the sublevel. The sublevel S, P, D, and F. And so there's a code or a number code that represents what each sublevel is. So if you're in the S block, the code is S equals 0, and the P block would be P equals 1, and then D equals 2, and F equals 3. So again, this tells the shape of an electron cloud. So your S cloud is more spherical, your P cloud is dumbbell shaped, your D cloud can get really complicated, but most of them are a clover leaf, and your F cloud, that one gets even more complicated, looks kind of like a flower. So again, it tells the shape of that electron probability cloud. It's also called the angular momentum. Let's look at the third principal quantum number. So this one tells the orientation in space. And how this is determined is if you had, for example, a p orbital, there would be 3 orbitals. They do a little code. They say that the middle orbital is a 0, and then you count up, so +1, and then you count down, -1. So whatever the middle orbital would be, the code would be, if you had an electron there that you were describing, it would be a 0 as the code. So that would mean that if you had a D, so if this was a D sublevel, its code, again, 0 is the middle, and then you count up, +1, +2, and then you count down, -1, -2. So it's just a way to say, hey, I have an electron in the first orbital, and it's a D. You could label it, it's the -2 D orbital. So that's what these quantum numbers do. Just they help to define exactly what electron we're talking about. And then for the spin, so this is known as M sub S. I forgot to say the orbital is M sub L, but this is known as the spin. So if you have an up arrow in your orbital, it has a number of +1/2. And if you have a down arrow, then you would have a -1/2. So again, it just tells if your arrow is going up and down. So to write these quantum numbers, I think it's helpful to first have the electron configuration and then sketch out what the orbital diagram is. So I'm just going to do one. Let's do oxygen. And I'm just going to ask, what are the 4 quantum numbers for the last electron of oxygen? So I'm just going to sketch out the electron configuration. And I really only need the last part. But it is 1s2, 2s2, 2p4. So I just want to look at this last part. Okay? So first of all, this last electron, what's the energy level? Well, it's a 2. So that is its n number or principal quantum number. The next number we get is, what is the shape of the cloud? Well, this is a p cloud that it's in. What's the code for a p cloud? Well, an S is 0, a p is 1. So 2, 1. The next 2 numbers, don't come from the electron configuration. They come from the orbital diagram. So I'm going to just sketch out the orbital diagram. So I have 4 electrons. So 1, 2, 3. And the electron we're talking about is the last one. So the last one that went in is that one. Okay, that purple one that I drew. So let's describe which p orbital. So which p orbital? We have 0, +1, -1. So the orbital that it's in is the -1 because it's the first one. And then next, the last number describes what the arrow is doing. Is it going up? Is it going down? Well, because it's going down, then it has a -1/2. But those are the 4 quantum numbers for oxygen. The AP board, again, won't ask you, hey, list the 4 quantum numbers for a certain element, but they could use this letter N to describe the principal quantum number. And that is very, very commonly used. So, and this is where it comes from. So no 2 electrons can have the same set of quantum numbers. This is called the Pauli exclusion principle. So because of this, you would never, ever, ever have in an orbital diagram 2 up arrows like that. If you did, then these 2 would have the same set of quantum numbers, and that's against the rules. It's called the Pauli exclusion principle. If you have 2 electrons that are sharing an orbital, one must spin up and one must spin down. The Pauli exclusion principle goes hand in hand with how you do orbital diagrams also. So let's talk about a little terminology. So we have principal energy levels, we have sublevels, we have orbitals. So when we look at n equals 1, or the first row on the periodic table, the only thing that's there is 1 sublevel. That would be S. When we look at the second row, n equals 2, if you look on the periodic table, there's an S and there's a P. So there's 2 sublevels. When you look at n equals 3, you have an S and a P, but then remember that that first D row is a 3D. So you have 3 sublevels. So you see the pattern? N equals 1 gives you the same number of sublevels, so 1 and 1. And principal level 4, we have 4 sublevels, S, P, D, and then that first row for the F starts with 4F. And each of those sublevels, it can be split into orbitals. So in your S orbital, there's only 1 orbital. So on the periodic table, when you look, this is your S block. Notice it's only 2 columns. So, and you could put 2 electrons in each orbital. So you only have 1 orbital. But when you look at your P block, you have 6 columns there. And if you can put 2 electrons in each column, then that means that there's 3 orbitals. So your 2p sublevel is split into 3. Okay? And it's described as px, py, and pz. And recall that the code is that the middle one is a 0, and then you count up and you count down. If you ever need to calculate the maximum number of electrons in an energy level, you can use this formula right here, 2n squared. So in my first energy level, or my first row, I could just count how many electrons are in that first row. So there's an electron with hydrogen, and then there's an electron with helium. So there's only 2 electrons total. But I can use the formula there. That gives me the same thing. So with the second energy level, how many electrons can be in that energy level? I could count it. So there's 2 s electrons and 6 p electrons. So that gives you 8, or I can do the formula. The third energy level, I have a 3s, a 3p, and a 3d, but there's no such thing as a 3f, so we stop there. So 2 times 3, so we have 18. So, and again, we get that 18 from the 3s, there's 2 electrons, the 3p, there's 6 electrons, and the 3d, there's 10 electrons. So that adds up to 18. So sublevels, so remember your sublevels are S, P, D, and F. And how many electrons are in each sublevel? Well, you just count the rows, or excuse me, count the electrons in each block. How many orbitals per sublevel? So you divide by 2. So I would have 1 in the S, 3 in the P, 5 in the D, and 7 in the F. Let's practice doing a few more quantum numbers, and this chart is in your packet, which you can use just to help clarify things. Let's look at helium. So helium 1s2, I can do the orbital diagram, which looks like that. So if you see my principal quantum number is 1, and if my principal quantum number is 1, the only choice I have is an S. An S is given the code of 0. And if the second number is a 0, the third number is always a 0 because an S orbital only has one orbital. And so if you start counting with a 0, that's all you have. Okay. And then the spin, either up or down, and I have the last electron is down, so I have the -1/2. So here's my 4 numbers. So 1, 0, 0, -1/2. Let's look at aluminum. I do have p electrons, and I just have 1 in that 2p. So between the electron configuration and the orbital diagram, I could do my numbers. So my first number is a 2 because it's row 2. And then I have a p. The code is a 1. And then which orbital is it in? It's in the first one, so that would be a -1 is the code. Because the middle is a 0, then you count up and then you count down. And then I have an up spin, so that would be a +1/2 because I have an up arrow. So 2, 1, -1, +1/2.